This is our Sun. It is known as a yellow dwarf star, and carries with it a variable temperature of about 27 million degrees. It was formed about 4.6 billion years ago inside of a giant spinning cloud of gas and dust scientists call a solar nebula. In fact, this is where all stars are formed. Oftentimes these nebulas serve as vast star nurseries, and scientists estimate that every second a new star is born. Although still young, it will someday reach the end of its life cycle, when fusion within its core can no longer occur. Every star in the universe has a life cycle, and every star goes through a period of infancy, youth, old age and death. Our Sun is no exception. Deep down in the core of our Sun, fusion keeps the star burning bright. Scientists estimate that if 1 second of solar luminosity were to be utilized in our nuclear power plants, it would be enough to keep them running for thousands of years. This fusion going on within the Sun's core is quite simple to understand. By definition, fusion is the merging of two or more elements to create another element. In the case of the Sun, when a new element is reached through fusion, it essentially grows older. In other words, its mass grows, and its output luminosity is increased. At the same time, gravity works against the Sun's core to keep it stable. As our Sun continues to grow in size and luminosity, it will eventually engulf Mercury and Venus, and be so close to the Earth that our oceans will evaporate and the atmosphere will be ripped away, insomuch that it takes on the appearance of what Mercury looks like now. In fact, scientists believe that the gravitational forces will be so intense that all but Earth's iron core will be stripped away. It is then that fusion will reach a point where it can no longer occur. Once the output of this fusion process results in Fe, which is iron on the periodic table, fusion will no longer be able to keep gravity from collapsing the core. This is because iron is an absorbing element. This means it carries with it the ability to absorb other elements. This means that when the Sun attempts to carry out fusion as it has done for millions of years, iron will absorb any new elements created, and be unable to fight the effects of gravity. This will result in a catastrophic collapse of the Sun's core. When the Sun's core collapses, all of that energy will come together to create a colossal explosion known as a supernova. However, this may not be the end result as scientists believe. This is because the death of a star is not always the same. Some stars when they explode become supermassive black holes, whereas others collapse into a neutron star, which is a super-dense star with a gravity nearly 500 billion times more powerful than the Sun itself. Either way, the resulting collapse will throw off a majority of the material from the Sun, creating a new planetary nebula. All of this will not occur for billions of years, so there is no worry of us being around when it happens. Scientists often wonder what such an event would look like, and with the star Betelgeuse reaching the end of its life, we may just get the chance to witness such an event. To learn more about Betelgeuse and what may happen in the near future, check out the link at the end of this video.